Howdy, my name is Stefan, and today we're going to be talking about implementation of the MIPS Datapath. So, implementing the MIPS Datapath has 3 steps. I'd like to call the 3 I's. That includes interpretation, identification, and implementation. You interpret the instruction, if possible, through the MIPS green sheet. Then you identify the data path, whether the register file is going to be used, the ALU, or the memory block. And lastly, you implement the controls into your data path components. So let's go through an example. In our example, we have a load word command. So this basically tells us to load the memory stored in this offset into the register T2. If we go into the MIPS data sheet, this is the definition we get for the load word instruction. So let's see what data path components we're going to be using. Here we have RS plus the immediate value. So this tells us that we're going to be using the ALU. Here we have memory being called. The memory block is called at this address. So we're going to be using the memory block. And RT is also going to be written into, and RS is going to be called. So we're going to be using the registers. So we know that RS goes through here, and we know that RT goes through here. And we also know that RT is going to be our write register destination. So that goes into this part. We also know that we have an immediate value that's -1, which is sign extended and goes into the ALU. So this ALU goes into the address of the data memory. So we call the data memory at the address RS plus immediate. That is T1 minus 1. And we read the data from there, and we write that back into T2. So this is our basic data path. Along with that, we are also having our program counter, which is incremented by a value of 4. Nothing else happens in the PC. So that is our data path. Now, we want to know what controls we're going to be using. So the controls we're going to be using are all of these right here. Now each control asks a certain question, let's go through what the first is asking. So regdst, register destination. So it's asking us the question, what goes into our write register? Does RT go into the write register, or does RD go into the write register? So our answer is RT goes into the write register. So we're going to be using this value, which is 0. And the second control is branch. It's asking us whether we want to branch at any point during this function. Now this is load word. We don't branch at any time during load word. So branch is going to be 0. No, we don't want to branch. Now memory read, let's see. So this is asking the question, do we want to read from data? Do we want to read this address? And our answer is yes. We're using RS plus immediate, and we're reading from that value. And we need to write that to RT. So yes, we want to read. So that's going to be 1. Memory to register. Do you want data to go from the memory to the register? Yes, we do. So that's going to be 1. ALU OP. So there's a preset code for each function in the ALU. And here we're using addition. So the ALU OP for addition is 00 because we're adding RS to the immediate. Memory write. Do we want to write into our memory? No, we don't. So that's going to be a 0. ALU SRC. Do we, what source are we selecting for our second ALU input? The answer is we're selecting the immediate value, which is present for an ALU SRC of 1. So that is going to be 1. Register write. Do we want to write into our register? And the answer is yes, we're going to write into RT. So that is 1. So this is basically how the data path is implemented for load word. Now they've given that the current value of the PC is 0x04000. So after going through this data path, when it's added to 4, we get 0x04000000, and 04, because it's added to 4. So this value goes through and is the new program counter value. So that is the program counter value. Let's see what's happening to T1. T1 is 1 and 7 zeros. So T1, so it was 1 and 7 zeros. Now when it's added to -1, it becomes 0x, I'm trying to subtract in hexadecimal, 0 F F F F F F F C. That's what I assume is happening. So basically that's what happens. And the data in that is written into T2. So that's basically what happens here.